In this video, you will learn about the preparation and properties of alcohols. In the chemical properties of alcohols, you will learn about combustion, substitution, dehydration, and oxidation reactions, and the preparation of alcohols through substitution, hydration of alkenes, and fermentation. Combustion of alcohol is when alcohols react with oxygen to form carbon dioxide and water. For example, propanol reacts with oxygen and heat is given out in this reaction. Then we have substitution reactions where alcohols react with hydrogen halides to form haloalkanes and water. For example, ethanol reacts with hydrogen chloride to give chloroethane, and the OH of the ethanol is substituted by a chloro group. The order of reactivity of the haloalkanes with the hydrogen halides is hydrogen fluoride is generally unreactive because it's a very strong bond, and hydrogen iodide is most reactive. In terms of order of reactivity of alcohols, the tertiary alcohol is most reactive, and then the secondary and the least reactive is the primary alcohol. The tertiary alcohol is most reactive because the three alkyl groups attached to the carbon bearing the hydroxyl group help in its high reactivity. Then there is dehydration reaction. Alcohols undergo dehydration reaction to form alkenes. So the alcohol in the presence of concentrated sulfuric acid will form alkene. It is heated in the presence of concentrated sulfuric acid, which is a dehydrating agent. In other words, it removes water from alcohol. For example, 1-propanol forms propene. If you have a compound like 2-propanol, it is dehydrated to give two possible products, 1-pentene and 2-pentene. Then there is the oxidation reaction. Alcohols undergo oxidation to form aldehydes, ketones, or carboxylic acids. The primary alcohol is oxidized to form aldehyde, which further gets oxidized to form carboxylic acid. This is in the case of primary alcohols. But if it's a secondary alcohol, then the product is a ketone. And if it's a tertiary alcohol, then there is no chemical reaction. Examples of oxidizing agents are acidified potassium permanganate or acidified potassium dichromate, and the acid could be hydrochloric acid. For example, 1-propanol, which is a primary alcohol, is oxidized to propanol and then further oxidized to propanoic acid. While for secondary alcohol, 2-butanol is oxidized to butanone. So the final product is a ketone. But if you have a tertiary alcohol, then there is no reaction. This oxidation reaction is used as a test to distinguish between primary, secondary, and tertiary alcohols. The oxidizing agent, such as potassium dichromate, is orange in color. After the oxidation reaction, the orange color changes to green because potassium dichromate gets reduced to potassium chromate. The color change would happen if the alcohol is primary or secondary. There'll be no color change if it's a tertiary alcohol. Regarding preparation of alcohols, alcohols can be prepared by substitution of a halogen with a hydroxyl group. So reacting a haloalkane with sodium hydroxide would give alcohol and a sodium halide. Halides could be fluoride, chloride, bromide, or iodide. In terms of order of reactivity, the alkyl fluoride bond is strong, so it does not react very readily. But the alkyl iodide bond is the weakest and it is the fastest reaction. For example, if you have 2-bromobutane and you react it with sodium hydroxide, you would get 2-butanol. In terms of order of reactivity of primary, secondary, and tertiary haloalkane, the primary haloalkane is least reactive, while tertiary is most reactive. Ethanol is also produced by fermentation. Yeast is added to the fermentation mixture, and enzymes such as invertase and zymase present in yeast catalyze the reaction. Fermentation takes place in 2 steps. In the first step, long-chain carbohydrates called polysaccharides and disaccharides are hydrolyzed with water. So this process is called hydrolysis. Hydrolysis of polysaccharides or disaccharides like sucrose yields glucose. And then the enzymes act on glucose to produce ethanol and carbon dioxide. Now, fermentation takes place under very specific conditions. The fermentation mixture must be kept dilute by adding water. If the concentration of ethanol increases, it could poison the yeast. The ideal temperature is from 25 degrees to 35 degrees. The enzymes work best at this temperature and may denature if the temperature is too high or low. Enzymes work at a pH of 4 to 6. Closer to 6, that is, the pH is slightly acidic. And fermentation must take place under anaerobic conditions, that is, there is no oxygen present. If oxygen is present in the mixture, it will oxidize ethanol to ethanol and then ethanoic acid. Lastly, alcohols can be prepared by hydration, that is, addition of water to an alkene. The double bond breaks and a hydroxyl group adds on, forming an alcohol. For example, if you add propene to water in the presence of dilute sulfuric acid, the final product is propanol. So in the workbook, you will get to practice questions on preparation and properties of alcohols. So good luck and enjoy.